Hey, welcome ladies and gentlemen to your 6.3 and 6.4 note guide talking about angles in degrees and radians. We're going to convert angles from degree to radians and vice versa. That's what this is saying right here. We're going to draw angles in standard position, and we're going to find coterminal and reference angles in degrees and in radians. It's kind of interesting because usually this is taught a little bit separately, and what I'm going to do is bring in degrees and radians together at the same time because it does give you better practice and a better understanding of how they kind of work together. Radian measure is just, it's initially at first glance it's going to look very, very confusing, but eventually, especially as you move through pre-calculus and calculus, it becomes very, very much as common and easier to work with than angles in degrees. So here's the first thing I'm going to do is I'm going to give you a conversion. I'm going to let you know that pi radians, and yes, that is the number pi, 3.14 approximately. So pi radians is equal to 180 degrees. So when you think of 180 degrees, that is pi radians. So then that goes to conclude then that 2 pi radians, and typically we don't write radians. We just, as soon as you see pi and 2 pi, when it comes to something to do with an angle measure, you know that you're dealing with radians. And conversely, angles, you definitely need to have a degree symbol, otherwise you're not going to know what you're doing. So angle measures that are in degrees, you need to have the degree symbol, but radians, you don't need to have the word radian after it. But I am doing it here because this is the first time you've probably ever been exposed to this. Radians, so 2 pi radians is equal to a full circle of 360 degrees. Now, with that said, what I'm going to certainly urge you to do, which is really, 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 really important, is to watch a couple videos that I didn't make but are better than anything I could make in cons. And I know you're doing cons anyway, so watch the con videos. And I have very specific ones that are good to watch. That's videos. The first one, and none of them take very long, but it'll give you a very good understanding of radians to degrees and understanding what a radian actually is, which is, by the way, just dealing with the length of radius. But intro to radians, you want to watch that video because that just tells you what a radian is and kind of gets you understanding that. The second video is degrees to radians. Radians. And then the last one is probably what you probably figured already, is radians to degrees. And it's really important to be able to do this, go back and forth with the degrees and radians throughout this course all the way into any other math course that you're going to take. So at this point I would pause this video and then go watch those three and then come back, because I'm going to assume that you have had some sort of experience or understanding of what a radian is, more so than just this conversion right here. So I'm going to still use them, but I'm not going to explain them nearly as good as what these con videos do. So, okay, so with that said, pause me. Okay, you're done pausing me. Now I'm going to talk about standard position of an angle, and again bring in radians throughout this lesson as well. So first of all, let me just say the initial side of a standard position of an angle is the x-axis. I'll just make it very simple. X-axis. That's this right here. This is the initial side, always the positive part of the x-axis. The terminal side is always where your angle ends. So as you're rotating, and keep in mind this right here is always at the origin, the terminal side is where you terminate or end. So this right here is your terminal side. So angles can exceed 360 degrees, I'm just reading right here, by wrapping around the origin multiple times. So like for instance, let's say this is, I don't know, 30 degrees. If we go all the way around and come back, that's not just 30 degrees anymore, that's 360 plus 30 degrees. So you're talking about 390 degrees. So it all depends on what they're going to be asking. I just wanted to make sure you understand, though, that you can continually rotate around the circle or the axes and keep adding 360 degrees to it, or 2 pi if we want to get it to that, which is, of course, one full rotation. Positive angles are drawn counterclockwise, and you know this is really interesting that, well, I can't write at the same time. Hold on a minute, I'll tell you what's really interesting here in a minute. So notice when I was rotating around the circle, I was going this way. That's counterclockwise. Have you ever thought to yourself, and I always think about how students probably always wonder about this, and I hope a teacher has told you, why we number the quadrants 1, 2, 3, and 4? It's always because of how we rotate around the unit circle, or the unit circle, which we're going to talk about soon, but around the axes. So with that said, as I've made a complete mess on my screen, negative angles are drawn, notice we're missing an N there, drawn clockwise. So this is really, really important, these two ideas. This right here, important. And we're going to be practicing it down here in just a moment. It says draw the given angle. Well, you're not even going to just draw the angle, you're going to also convert to other type of angle measure. So if it's drawn or given you in, like in this number 1, it's given to you in radians. Notice it doesn't say pi radians, it just says pi. That is going to equal 180 degrees. How do we know that? From above and from the videos we just talked about. So let's draw that angle. Here's the initial side. We're going to rotate around to 180 degrees. So that angle actually is a straight angle right there. And I'm going to say pi or 180 degrees. Okay, so that's what I want to do. So number 2, we have negative pi over 2, and I just want to say again, we know that pi is 180 degrees, so the fastest thing to do to convert to the other type of angle measure, which would be degrees, is to literally, instead of pi, put 180 degrees in, and that's what you would have seen in the con video, and so that is giving me a negative 90 degrees. So what does negative 90 degrees or negative pi over 2 mean? Well, you're starting in standard position right here with the initial side, and you're not going this way because that would be a positive angle, and notice the angle is not positive. You're going to go negative, and that's clockwise. So you're going to go down, rotate clockwise to 90 degrees or to pi over 2 radians. So this angle right here, that 90 degree angle, is going to be right here though. Notice there's the initial side, and here's the terminal side, and this is the angle that it's giving me right there. Now if you drew it in that first quadrant, you're wrong. That would be a positive pi over 2 or a positive 90 degrees, and this is not a positive angle. 400 degrees. Well, that's fun because as soon as you get over 360, then you get to rotate a lot. Now this is a positive angle, so we're going to start here. We're going over 90 degrees, 180 degrees, 270 degrees, and now we're 360, and we're going a little bit more and to get to 400. Now I'm going to draw my terminal side, and that in there is not a very big angle, and if you want to calculate it, like the actual smaller angle component, which is called a reference angle, which we're going to talk about down here, you can just go 400 minus 360, and you'll see that is 40 degrees, which of course makes sense, right? 360 plus 40 more gives me 400 degrees. Now, we have to convert 400 degrees over to radians. This we haven't done, and again, if you didn't see the videos that I had asked you to do, this would be a little bit more challenging. But you take what's given, I put it over 1. My conversion rate is I want to get rid of my degrees, so I put that down here. It's 180 degrees, and I put pi up here. We're multiplying it by this conversion factor. And then we're just going to multiply right across. We have 400 pi over 180, and then you just need to simplify. So you have 40 over 18, and that will reduce to 20 pi over 9. So 400 degrees is the same thing as 20 pi over 9, which is awesome. Okay, Now I am going to erase this right here because I'm kind of in my space for my next problem. So down over here we have negative 225 degrees. So we know that, again, it's negative, so we're not going counterclockwise this way, we're going the other way. So I'm going to go this way. I'm at negative 90, negative 180, I'm sorry. Oops, I don't know what just happened there. That was really weird. Negative 90, negative 180, and we don't want to go all the way to the y-axis because that would give me negative 270, but we're going to stop right about right here. I'm going to draw my terminal side, and you know what that is, exactly what I need to draw. Now I'm going to convert that over to radians. So it's, I don't have a lot of room here, negative 225 degrees over 1. I put my conversion factor, pi over 180 degrees. I multiply across, I simplify it, and I'll end up with negative 5 pi over 4. Just a little bit of fraction work, and that's really, really good practice. So negative 225 degrees is the same thing as negative 5 pi over 4. Okay, so, and you know what, I'm going to kind of come back over here and I'm going to cloud up these answers so that it's kind of clear. So I drew my angles and I wrote my other type of angle in there, and there we go. Okay, so that is just a little bit of conversions. Now let's get into the reference angles. It says the angle formed by the terminal side and the x-axis. Gosh, we use this all the time in pre-calculus. I always tell my students, never, ever, ever, ever use the y-axis for your reference angle. You're always going to the closest x-axis, and it always has to be positive. So a reference angle isn't negative ever. So to give you an idea, if you were rotating around, like kind of like, I don't know, we don't have a really example up there by 1, 2, 3, and 4, the ones that we just did. But if you're rotating around from the initial side around here to this angle, so here's my terminal side, and now I'm going to erase this just to kind of clear it up a little bit. So what I have here is I have this terminal side, and here's my initial side. The angle that we initially drew was this angle right here. If we want a reference angle, we're always looking at the closest x-axis, which of course is right here, right? There's the closest x-axis. And I'm going to change my colors here just so that you can kind of really see what I'm talking about. This right here. And we want to know what that angle is because that will be your reference angle. And in this case, you would take, you know, sometimes you take the big angle theta, subtract it from 180, sometimes you subtract it from 90, sometimes you add 180. It all depends on the position of the angle. But it's always positive. It doesn't matter. That doesn't matter. All you want is the angle closest to the x-axis, because eventually what we're going to do is we're going to create a triangle that's a right triangle and use trigonometry to solve that. So that's kind of not something you need to know right now, but I am letting you know that that is what a reference angle does for us, which is very, very powerful. So reference angles, very important. So right here it says use, oops, I've kind of lost my spot there. Actually, I want to change the instructions here. This is kind of the power of being able to, I'm going to get rid of this. I didn't like the way this was written. I'm going to say just find the reference angle for each. That's all. We're not converting or anything like that. If it does help you to convert it into degrees because that's what you're more used to, do that. But here's what we're going to do. Now I still draw. I know it says drawing up above, but I changed the words here. So I'm going to first draw in my 100 degrees, which is about right there. And if this is 100 degrees right here, I need to find this angle right here. And you'll notice I even create right triangles because that's kind of what we're eventually going to do. Now that drawing is not so good, but I'm just letting you know theta is this angle right here. So what do? Well, the reference angle in this situation is going to be theta, which is going to be 180 degrees, which is that straight angle, minus 100 degrees, which gives you 80 degrees. The reference angle for that, let me just change the colors here. For for this angle right here is the other part of that 180. So you just take 180 minus that angle of 100 degrees and you'll get that 80 degrees. And again, it totally depends on what it looks like. I'm going to pause with this number 6 and go right to number 7, because that, if you remember, we did that one right, oops, as I just tag my thing here. We did that one right here, so we already know what the picture kind of looks like. So let's kind of just draw that really quick. So again, if we cycled all the way around, our terminal side would end about right there. But I don't want to know the 400 degrees, I just want to know the reference angle. And again, you're taking that terminal side and bringing it down to the x-axis, closest x-axis, to create a right angle. But what I want to know is this angle right in here, right there. That's going to be theta. And again, in this case, it's a little different, because what we did was we went all the way around to 360 and went up 40 more degrees to 400. So the reference angle in this case is that 40 degrees. So in this case, if you want to get fancy, it's 400 degrees minus 360 degrees, and that's where we got that 40. So every situation is going to be a little different. Students sometimes really want a written rule, and in this situation there isn't one. So you just have to look at your situation and decide what it is from there. So this is theta is equal to 40 degrees. That's my reference angle. So negative 225, again, we drew it already above. So I'm just going to draw the part that's important, and I'm going to draw that. I want to know what this angle is right here, because again, that's coming down to the x-axis, the reference angle. So we knew that this right here, if you want, again, if you came around, that's 225. You can see that you can do this all different types of ways, but you could take 180 away from the positive 225 to find that little inside angle, which is what I did. I went, because again, remember, reference angles are positive, so I went 180 minus, well actually this one, I'm sorry, what did I do? I went here. I knew that this is 135 degrees, because 225 plus 135 gives you that 360, that whole circle, and then you could take that 135 from the 180 and gives you 45 degrees, which is this angle, again, right there. But I'm going to say this again, that you can do this a couple different ways, and there's not one right way as long as you get the right answer. So just look at your position, figure out, should you add 180, subtract 180, add 90, subtract 90, do 360, 270, all those kind of wonderful things. Okay, so let's talk about this radian measure one. I'm going to switch it over, because just at this point, just to kind of give our mind a break here, we know that this is negative 60 degrees if you put 180 in there, in for pi, I should say. And if you look at negative 60 degrees, that's going to bring us right down to here, because again, it's clockwise, because it's a negative degree. And so we, again, I'm just going to create that right triangle to the x-axis, just kind of get you used to doing that. And this here, right there, is the theta, or the reference angle. Again, reference angle is the terminal side going right up to the closest x-axis and finding that angle. So interestingly enough, to get to that, we went negative 60 degrees, but the reference angle itself, because it has to be positive, is 60 degrees. Or, more importantly, you could just say pi over 3. So that is how you do your angles in general, how to convert from radian to degrees and vice versa, and messing around a little bit with those reference angles, which we use a lot. So that is this part of your note guide. Down here where we're starting to talk about coterminal angles, that's going to be our part B. It doesn't take as long as this part to explain, but again, just to kind of, what I would do is take and do a little bit of the practice, do some of the cons, and then come back and watch the part B, just to give yourself a little bit of practice. Any questions you have, of course I'm available, so we'll talk face to face. Take care.